Let's go ahead and think of this row of memory here as being main, for instance, here. And I'm going to go ahead and replace all these garbage values with an actual value that I care about. And the actual values that I care about, we're going to call x and y, just as before. So each of these Oscars happens to be 1 byte, but an int is 4 bytes. So thankfully, from our friends in the prop shop, we have these bigger integer-sized blocks. And I'm going to go ahead and slide this in here. And we're going to think of this in a moment as x. And indeed, I'm going to go ahead and call this x with a marker. And then I'm going to go ahead and give myself another integer of size 4 and put it down here. And we're going to think of this as y. And recall, what do I initialize these values to? Well, the value 1 initially and the value 2. But then I called the swap function. And the swap function has 2 arguments, a and b. And those by design become copies of x and y, because I passed in x comma y. And I defined swap as taking a comma b. So I think what I need to do physically here is now think of this second row of memory as now belonging to the swap function, not to main. And inside of this second row of memory, I'll think of this as belonging to swap. And within the swap row, I'm going to have another integer of size 4. And we're going to call this one a, as down there. Whoops, a. And then I'm going to have another chunk of size 4. And we're going to call this b. And again, because those are just the arguments, x comma y, otherwise now known as a comma b, I copy 1 and 2 into those values. But swap has a third variable. Brian proposed a temporary variable. So I'm going to go ahead and give myself 4 more bytes, thereby getting rid of whatever the garbage value is there and actually setting it to an integer called temp. So I'm going to go ahead and call this thing temp, TMP. And what did I do first? I set temp equals to a. So temp equals to a. So if a is 1, temp is 1. Then what did I do? I then did a equals b. So b is 2. A is 2 as well. And then lastly, what did I do? I did b gets temp. So I have to go ahead and change this to be whatever the value of temp is, which is now the number 1. So you can see that swap is correct insofar as it is swapping the values of a and b. But the moment swap returns, these return to being thought of as garbage values. Main is still in the middle of running. Swap is no longer running, but these values stay there. So those are garbage values. We happen to know what they are, but they're no longer valid, because when I go to print out x and y for the second time, what are x and y? They're still the same. And so this is to say, when you actually write code that takes arguments and you pass arguments from one function to another, those arguments are copied from one function to another. And indeed, x and y are copied into a and b. So your code may very well look correct in that it's swapping correctly, but it's only swapping correctly in the context of swap, not touching the original values. So what I think we need to do fundamentally is re-implement swap in such a way that we actually change the values of x and y. But how can we do this? Brian, if we could call in someone here, how could I conceptually change my implementation of swap so that it somehow empowers me to change x and y, not change copies of x and y? Like, what could I pass into swap, Brian?
Igor is suggesting that we use pointers instead.
Yeah, so perhaps a leading question here today, but pointers would seem to give us a solution, right? If pointers are essentially like a treasure map to a specific address in your computer's memory, what I should really do from main to swap is pass in not x and y literally, but why don't I pass in the address of x and the address of y so that swap can now go to those addresses and actually do the sort of swap that Brian enacted in person. So give the function a sort of map to those values, pointers to those values, and then go to those values. So how might I do this? Well, the code has to be a little different now. When I call swap this time, what I really need to do is pass in the addresses of these 2 variables. So I don't necessarily know what those addresses are, but for the sake of the story, we can just assume that this address, for instance, is like 0x123, and then 4 bytes away from that might be 0x127, for instance. But again, it doesn't really matter what it is, but they do have addresses x and y. So a pointer, recall, tends to be pretty big. So we needed to get out a bigger piece of wood, 8 bytes, that represents a pointer. And I actually need to use a bit more memory in swap now. If I now declare a to be not an integer, but a pointer to an int. That is an int star variable. I could call this thing a now, and I could store in it the address of x, like 0x123. If I then change the definition of b to be not an integer, but a pointer to an integer, that is another int star, which happens to be 8 bytes. I'm going to use a little more memory for this thing, but that's OK. And its name is going to be b now, and it's going to contain 0x127. I still need a temporary variable. But that's fine. I just need 4 bytes for that, because the variable itself just needs to store an int, like Brian temporarily stored it in a glass. So I just need an additional 4 bytes like before for that. And now let's just consider the logic. Here's main, and swap is now using these 2.5 rows of memory, and that's fine. It's growing upward as I proposed. X is at address 0x123. Y is at address 0x127. Therefore, A and B, I propose conceptually, like Igor proposed, store the addresses of A, X, and Y respectively. And now my code, I think, needs to say this. Go and store in the variable temp whatever is at the address A. So you can kind of think of this as being an arrow down here. Follow the arrow. OK, what is at address 0x123? The number 1. So we put 1 in temp just like before. Then what do? Well, now I'm going to go ahead and change not the value of A, but I'm going to change what is at the location in A to be whatever is at the location in B, which is like an arrow pointing down here, 0x127. So I'm going to change this 1 now to be a 2. And the third and final step, recall, is for me now to go not to B, but to go where B points to, which happens to be Y, and change that to be the value of temp, which of course is up here. And at this point in the story, it's still just 3 lines of code. They're different types of lines of code. It's 3 lines of code. But when swap is done executing, notice what we've done. We have successfully swapped x and y by letting swap go to those addresses, as opposed to just naively getting copies of the values therein. Now, even though this code is going to look a little cryptic, it's frankly just an application of the logic we've seen thus far. I'm going to go ahead and go back to my old buggy version, and I'm going to change the definition of swap to say that it doesn't take 2 integers, a and b, but 2 pointers to integers, a and b. And the way you declare a pointer, recall, is the type of variable you point at, followed by a star, and then the name of it. And we haven't seen it, admittedly, in the context of a function taking parameters yet, but it's quite simply that. I added the stars. Down here, I need to say, store in temp whatever is at A. How do I express go to A? Just add a star here. How do I express go to A and put whatever is at B? I add stars there. How do I say go to B and store whatever's at temp? I add 1 star there. So temp is just a simple integer. Like it's just an empty glass like Brian had. There's nothing fancy there, so we don't need stars around temp. But I do now need to change how I'm using A and B, because now they are addresses that I actually want to go to. There's no need for the address of operator in this context. But up here, I'm going to need to make a change. I do need to change the prototype to match. So that's just a copy paste. But I bet you can imagine what lastly needs to change. When calling swap, I don't want to pass in naively x and y, because again, they're going to get copied. I want to pass in the address of x and the address of y, so that swap now has sort of special access to the contents of those locations in memory, so that it actually can make some changes therein. And that indeed, if I now recompile this program, make swap, and I do dot swap and cross my fingers, voila, now I have successfully swapped lines of code. So last week, if you were wondering perhaps like why we didn't show you how to do swap, we could have, and we didn't need a special function. You don't necessarily need pointers if we did all of this in main. But I'm trying to introduce an abstraction, this function that does swap, just like Brian swapped those glasses for us. And to pass values from one function to another, you do need to understand what's going on in your computer's memory so that you can actually pass in little breadcrumbs again, treasure maps to those locations and memories, again, thanks to these things called pointers. All right. Well, let me propose and emphasize then that this design of the heap being up at the top where malloc uses memory and the stack being at the bottom where your own functions use memory, like this is a problem clearly waiting to happen. And those problems actually have names. And some of you who have programmed before might know some of these terms, either heap overflow or stack overflow. And in fact, many of you might know stackoverflow.com is just a website. Well, there is an origin story to its name. A stack overflow refers to the process of calling a function so many times that it overflows the heap. That is, every time you call a function like I did here, you use more and more rows, so to speak, of memory. And if you call so many functions again and again, eventually you may very well run over the area of memory called heap. And at that point, your program will crash. Like there is no fundamental solution to that problem other than don't do that.